I'm Emerald Robinson. In this What Is video, we're going to take a closer look at asteroids. Asteroids are small planetary objects orbiting the sun. Their hard, rocky bodies differentiate them from comets, which are made of small rocks, dust, and ice. Asteroids range in size from a few meters across to objects large enough to trap smaller asteroids in their gravitational pull, like moons orbiting a planet. Asteroids lack the gravitational force needed to round out like planets, so most are irregularly shaped. They have no atmospheres and are not geologically active. Hundreds of thousands of asteroids exist in the solar system, most occupying an area between Mars and Jupiter called the asteroid belt. Despite their numbers, the combined mass of all solar system asteroids only equals the mass of the Moon. Asteroids that cross the Earth's orbit are called near-Earth asteroids. Astronomers have discovered approximately 4,500 near-Earth asteroids, including up to 1,000 with 1-kilometer diameters. At least one asteroid with a 4 to 10 meter diameter hits the Earth every year. Impacts with large asteroids have triggered planet-wide extinction events several times in the Earth's past. The last mass extinction event wiped out the dinosaurs. A similar cataclysm could seriously test humanity's ability to survive, so astronomers track large asteroids capable of causing such impacts. Going back to the beginning of the solar system, asteroid impacts helped grow planets, adding to a forming planet's mass while clearing its planetary orbit. An impact with an enormous asteroid as large as Mars ripped a chunk off the early Earth, creating the Moon. Asteroids have changed little since the beginning of the solar system, over 4.6 billion years ago. Their composition could teach us much about those early years. As for the future, rare minerals found on asteroids could provide raw materials for space exploration. And that's the rock-hard truth about asteroids.
Our dear planet Earth is in the hotbed of cosmic activity this year. Let's recap some recent news. A meteor explodes over Russia, an asteroid barely missed crashing into Earth, and later this year, we will see a comet in the skies that will shine brighter than a full moon. Asteroids, comets, meteors. Ever wondered about the difference among those three celestial bodies? Asteroids are usually made from space debris like rock, although some are comprised of nickel or iron. The bodies range in size from a boulder to hundreds of miles in diameter. They orbit around the sun. Some asteroids have struck the Earth in the past, but most don't survive passing through our planet's atmosphere. Comets are essentially space equivalent to snowballs. Unlike the asteroids that are mostly found in the inner part of the solar system, comets begin their life outside the solar system. The cosmic balls consist of frozen gases, dust, and rock. Measuring the size of a quaint town, comets' temperatures increase when their orbit brings them close to the sun, resulting in the spewing of gas and dust, which creates a glowing head along with a tail that sprawls away from the sun for millions of miles. Meteors are mistakenly referred to as shooting stars, but they are actually comprised of dust grains or rocks. They are generally smaller than the asteroids. When they get near Earth's gravitational pull, they are sucked into the atmosphere and descend downwards. They usually burn up before hitting the ground, but often let off a flash of light. Sometimes they are big enough to make it to Earth and are then known as meteorites.
A while back, I told you about some rogue asteroids whose threat to Earth, while mathematically minuscule, is nonetheless real. This raises the question of what our plan is for stopping one of these dastardly asteroids if we need to. Turns out, we have three. In 2007, NASA presented the United States Congress with 3 ways to save the world from an asteroid on a collision course with Earth. Each plan has its upsides and its downsides, but together they cover pretty much every doomsday scenario Hollywood could dream up. The first plan: proposes using a slow push, a strategy that involves sending a spacecraft to a threatening asteroid and then messing with it to alter its orbit. For example, one of these methods, called ablation, would use a huge mirror to focus sunlight on a small spot on the asteroid. The heat generated from the beam would vaporize material on the surface, creating a jet of gas and debris with just enough force to divert the asteroid's path. Another plan calls for sending a spacecraft that's so massive that it would serve as a gravity tractor. By flying a supermassive vehicle alongside an asteroid, gravity could pull the space rock out of the way. But the slow push scenario that experts like the most is called the space tug. In this version, a craft attaches itself to the asteroid and fires its propulsion systems to nudge the rock onto a different course. All very elegantly simple, no? Actually, no. The problem with slow push plans is that they all involve inventing tricked out new spacecraft and having them rendezvous with a rock millions of miles away. That's a lot of logistics. Combine that with the fact that these techniques would only work on rocks less than 300 meters across, and it's time to look for plan B. So what about brute force? I mean, you're trying to destroy a rock here, so let's not overthink it. That's where the second plan comes in, kinetic impact. NASA's actually described this as the most mature approach, but the whole idea of it turns me into an instant 7-year-old. You just get a Delta IV rocket, you saddle it up with some high-density impactor, say like a huge chunk of depleted uranium, and then you aim it away from your face and toward an asteroid, and kablamo! It would be awesome! But again, there are problems. Kinetic impacts are only effective on smaller, solid objects, and some of the bad guys out there roaming around are basically just several square kilometers of rubble held together by gravity. An impact could potentially just turn them into many, many little asteroids instead of one big one. So that leaves us with only one other option, and you may know what I'm talking about here. The nuclear option. NASA physicists say it would take just a small megaton neutron bomb to divert the path of even a large asteroid. In computer models, they found that the nuclear option was 100 times more effective at deflecting asteroids of all sizes than any of the non-nuclear options. So there's our solution! But obviously there are some drawbacks here. First of all, experts point out that you can't just launch some leftover warhead. You need a specialized nuclear device on a heavy-lift launch vehicle and the ability to time the explosion precisely. And even though the explosion would be most effective if it took place on the asteroid's surface or even inside of it, the official recommendation is to do a standoff explosion, detonating the bomb during a flyby. This cuts the risk of blasting the asteroid into a bunch of radioactive fragments hurtling toward Earth, which would not be ideal. But finally, there's this little snag. The International Comprehensive Test Ban Treaty prohibits nuclear explosions in space, even for scientific research. So a plan like this would require international cooperation and approval. Now, hopefully, the prospect of all of our lives turning into some bad 90s disaster movie would be enough to get the nations of Earth to work together on this. But let's just say, I hope we never need to find out. Thanks for watching this episode of SciShow. Again, I hope that we never need to use any of this information, but it's good that we have it anyway. If you have any questions or comments or suggestions, please leave them.